Hey, what's up guys? Welcome back. In the previous video, we saw how to implement queue data structure using Python. In this video, we are going to see how to implement Deque data structure using Python. Deque is also known as double-ended queue, and this is how a typical Deque data structure looks like. So the main difference between Deque and queue data structure is that you can enqueue and dequeue from the front end as well as enqueue and dequeue from the back end in the Deque data structure. In queue data structure, you can only enqueue from the back end and dequeue from the front end. In case you don't know, uh, enqueue means whenever you add an element to a Deque, then that process is called enqueue process, and whenever you remove an element from a Deque, then that process is called as dequeue process. Now let us take a look at the operation. So we are going to be using Python's list as a placeholder. So the left side is going to be front end and the right side is going to be the back end. Now I'm going to enqueue front. So I'm going to add 2 to the um, Deque. So 2 is now is added to the Deque. Now again I'm going to enqueue front. I'm going to add 3. Here we can see 3 has been added to the Deque. Now I'm going to enqueue from the back end. So I'm going to enqueue 1. Now 1 has been added in the back. So now the Deque has 3 to 1 elements in it. Now I'm going to enqueue from the front. I'm going to add 5 to it. So now 5 is present in the left side. So 5, 3, 2, 1 elements are now in the Deque. I'm going to dequeue now, dequeue from the back. So the element which is going to come out is 1. So here we can see 5, 3, 2. Now I'm going to again dequeue from the back. Now 2 comes out from the Deque. And now again I'm going to dequeue from the back. And now the only element which is present in the Deque is 5. Now again I'm going to dequeue from the front. Now the element which is going to come out is 5. It doesn't matter if you dequeue from the front end or dequeue from the back, because 5 was the only element left in the Deque. So uh, I'm going to use dequeue front. So 5 has come out now. Now the Deque is empty. Okay. Now let us implement Deque using Python. So we are going to be using Python's class, and this class is going to have these elements. IsEmpty method is going to return us whether the Deque is empty or not. EnqueueFront will add element to the Deque from the front end, and DQFront is going to remove the element from the front end. Now enqueueBack is going to add an element from the back end. DQBack will remove the element from the backend. Peak front will give us the will return us the element which is present in the front end. It's not going to remove the element from the Deque. It will just tell us which element is present in the front end. And peek back will let us know which element is present at the back end. Length or size method is going to return us the size or length of the Deque. Display will just display the Deque. Okay, now let's start to code. First things first, I'm going to initialize a class called Deque. Okay, and now I'm going to initialize init method, also known as constructor method in other programming languages. So def double underscore init, and the first argument is going to be self. Now I'm going to use Python's list as a placeholder. So self dot my, I'm gonna name it as my Deque. Okay. All right. Now that we have constructor method ready, let us implement these methods to this class. So the first method is empty. So def is empty. Self, apart from self, it's not going to accept any other parameters. So I'm going to return self dot my Deque double equal to empty list. So if this condition turns out to be true, then it's going to return true. If it turns out to be false, it's gonna return false. Okay. Now I'm going to implement enqueue front, def enqueue front. apart from self, it is going to accept another parameter called value. All right. So self dot my deck dot insert. I'm going to insert this value at the 0th position, because here in this figure you can see the front end is on the left side, and we always have to insert the element at the 0th position. So that's why I'm using 0th index, and I'm going to pass value to it. Okay, so this is enqueue front. Now the next method, I think it's gonna be deque front. So deque front. So it's now going to accept any parameter apart from self. So before we deque the deck, we need to check whether the deck is empty or not. So for that, if I'm going to call self dot is empty method is empty. If this condition turns out to be true, I'll just print the deck is empty. Deck is empty. Okay. Else we can, if the deck is not empty, then we can remove the element from the deck. So I'm going to call ele, and I'm going to take this self dot my deck, and I'm going to get the value from the 0th index. Self dot my deck equals self dot my deck. I'm going to use slicing method for this. So I'm going to save the elements from first index all the way till the end. Okay, since we have removed the first element from the deck, we have to consider, we have to reassign the elements to my deck from first index to all the way till the end, and then we can simply return ele. Okay, so this was the deque front. Okay, deque front. Okay, so what we are doing here is we are checking whether the deck is empty. So self dot is empty. If this is true, then we'll just print out, and we have to return. Okay, forgot to return. So deck is empty. So it'll just print out deck is empty. Else we can remove the element which is present at the 0th position. So I'm just using this ele element to hold the first element which is present at the 0th index. Then after that, I'm calling self dot my deck, and I'm considering the elements from the first index all the way till the end, and I'm again reassigning it to the self dot my deck. Okay, so this is how you can remove the first element which is present at the 0th index, and again, and then later I'm returning the element which was present at the 0th index. Okay, so that was about the deque front. Now the next method is enqueue back. So def enqueue back self, and again enqueue back will accept another parameter apart from self, that is value. So self dot my deck dot append, I'm going to append the value. So what append method does is it will basically appends the value in the backend. Okay, so here it's gonna append the element from the backend. So that basically means enqueue back. Okay, so yeah, we're done with this method. Now next, it's gonna be deque back self. Apart from self, it's now going to accept any other parameters. Now again, we need to check whether the deck is empty or not. So I'm going to copy and paste this same here. All right, and now element, and I'm going to call self.myDeck, and I'm going to use negative indexing. Python also supports negative indexing. So I'm going to pass -1. -1 basically means that the element which is present at the last index. -2 will tell you the element which is present in the last second index. Okay, so self dot myDeque of -1 will give you the last element. And now I'm going to call self dot myDeque again equals self dot myDeque, and it is going to have the elements from 0th index to all the way till -1, but not including the element which is present at the -1 index, -1 index. Okay, so it will go from 0 to all the way till the end, but not including the element which is present at -1 index. Okay, -1. So I'll just return ELE. Okay, so now we are done with Deque back. Now let's implement peek front and peek back. So def peek front will basically uh, returns the value uh, which is present in the front. It's not going to remove that element. It will just let us know what element is present. So before we do that, we again have to check whether the Deque is empty. If it is empty, it'll just print out the Deque is empty. Else we can basically return self dot my Deque of 0th index. So since we are defining peek front, so it's going to return the element which is present at the 0th index. Okay. Now def peek back self, and again I'm going to copy and paste the same thing here. So if the Deque is empty, it'll just print out Deque is empty. Else we can return of -1. Okay. Now length. Now let's implement length and then display. Okay, so def length. Okay, it'll just return the length of Deque. So right, now we are done with the length. Now let us do the final method, that is display. Display will just print the Deque. So self dot my Deque deque. All right, I think we are basically done with all the methods. Now let us create an instance of this class. So I'm going to call it as D. All right, let's run this. Hopefully there are no errors. So yeah, it has run successfully. Now first I'm going to call isEmpty method. Have to print this. So it should return as true now because the Deque is empty. So yeah, it has printed true. Now let us add elements to it. So I'm going to enqueue front first. I'm going to add 2, and I'm going to enqueue from the back. I'm going to add 3. So sorry, 3. Now if I call display method, the Deque should have 2 and 3 in that order. Okay, so 2 comma 3. So here we can see the Deque has 2 comma 3. Now I'm going to enqueue front end. I'm going to enqueue from the back once again. So enqueue back, I'm going to add 6, and d dot I'm going to again enqueue from the front. This time I'm going to enqueue 7, and if I execute this and call display, now the Deque should have 6 comma 2 comma 3 comma 7. So here, oh sorry, um, yeah, it should have 7 comma 2 comma 3 because we have enqueued from the front. We have enqueued 7 from the front, and 6 from the back. So here we can see the 7 is has been enqueued from the front and 6 has been enqueued from the back. So 7, 2, 3 and 6. Yeah, that's correct. Now dequeue the deck. So I'm going to dequeue from the back. So it should remove the element 6. Yeah, it has been removed. Now let's call display. And here we can see 7, 2, 3. That's correct. Now I'm going to dequeue from the front. Dequeue front. It should remove 7. So here we can see 7 has been removed. So I'm going to call display. Now the elements which are present in it are 2, 3. And now I think we enqueued, we checked is empty, we enqueued from the front as well as we dequeued from the front, we enqueued from the back as well as from the dequeued from the back. And yeah, now we have to check peak front, peak back and length. Okay, so yeah, let's add few elements. Enqueue back, I'm going to add 9. Enqueue front, I'm going to add 10 to it, and I'll call display. Yeah, that's correct. 10 to 39. Now I'm going to call peak front method. It should return us the value 10, but it should not remove the value from the deck. So sorry. Yeah. Now if I call display, the 10 will be still in the deck. So yeah, that's correct. 10 is still in the deck. Now if I call display, sorry, not display, peak back, it should give us 9. That's correct. If I call display again, yeah, 9 has not been removed from the deck. Now the final method is length. It should return us 4 because 10, 2, 3, 9 are the elements which are present in the deck. So the total count is 4. And here we can see it has returned 4. And now let us try to empty the deck. It should print out this message and it should also throw an error. D dot doesn't matter. So d dot deque front, I'm going to randomly deque front and back. So 9 deque, I'm going to deque front. 2 has come out. Not NQ, sorry. Deque front. 3 has come out. If I call d dot display, yeah, now the deck is empty. If I try to deque again, it should print out the deck is empty. And here we can see deck is empty. All right, I we hope the concept is clear, and we also implemented all the elements which were listed here. And yeah, that's how you implement deck data structure using Python. I hope you guys enjoyed this video. I'll see you guys in the next one. Until next time, take care and be safe.